For millennia, we've gazed up at that faint, shimmering band of light stretching across the night sky, a celestial river we call the Milky Way. We learned it was our home galaxy, a vast, swirling disk of stars. But what if I told you that everything we thought we knew about its size was wrong? That the galaxy we inhabit is far, far larger than we ever imagined? Prepare yourself, because recent discoveries are forcing us to completely rethink our place in the cosmos. For decades, astronomy textbooks have told us the same story. The Milky Way's stellar disk, the part containing most of its stars, gas, and dust, spans about 100,000 light-years across. It's a number so vast it's hard to comprehend, yet it's been the bedrock of our galactic model. This was the map we used, the boundary we accepted. But science is a journey of constant discovery, and sometimes the map needs to be redrawn. Astronomers started noticing anomalies, things that just didn't fit. Distant stars and star clusters, which should have been outside our galaxy, were behaving as if they were still gravitationally bound to it. The old map was starting to look incomplete. The breakthrough came from an unexpected source: stellar seismology. Just like seismologists study earthquakes to understand Earth's interior, astronomers can study the vibrations, or starquakes, on the surface of stars. These oscillations reveal a star's internal structure, its mass, and most importantly, its true age and distance. By analyzing a huge dataset of stars from missions like the Kepler and Gaia Space Telescopes, a team of astrophysicists made a startling discovery. They found a population of stars far beyond the 100,000 light-year edge, a population that was unmistakably part of the Milky Way's disk. The evidence was undeniable. Our galaxy's stellar disk doesn't just abruptly end. Instead, it extends much, much farther out. The new measurements indicate the Milky Way is at least 200,000 light-years, across double its previously accepted size. Imagine thinking you live in a city, only to discover it's actually the size of a continent. This isn't just adding a few suburbs. It's a fundamental redefinition of our galactic home. This extended disk is populated, albeit more sparsely, with stars that share the same rotational pattern and chemical composition as those closer to the center. We weren't just looking at rogue stars. We were looking at the true, vast expanse of our own galaxy. So, how did we miss this for so long? The answer lies in the darkness. The outer reaches of the galactic disk are incredibly faint. The stars are few and far between, and the interstellar gas is much less dense, making it nearly invisible to traditional telescopes. It's like trying to see the faint glow of a candle from miles away on a foggy night. It took the precision of stellar seismology, combined with massive star surveys, to pierce through this obscurity and reveal the true scale of our galactic home. We were essentially blind to 2/3 of our own galaxy's stellar disk. This discovery doesn't just change a number in a textbook. It sends ripples across multiple fields of astrophysics. First, let's talk about mass. A bigger galaxy means more stars, more gas, and more dust. The total stellar mass of the Milky Way might be up to 4 times greater than we previously calculated. This has huge implications for our understanding of dark matter. The visible matter we see is only a fraction of a galaxy's total mass. The rest is this mysterious, invisible substance. A more massive, stellar disk changes the equation, forcing us to recalculate how much dark matter is needed to hold our galaxy together and how it is distributed. The entire gravitational framework of the Milky Way is now up for review. Then there's the story of how our galaxy was built. The prevailing theory is that large galaxies like ours grow by consuming smaller dwarf galaxies over billions of years. A larger disk provides a much bigger target for these cosmic collisions. It also means that the signatures of these past mergers might be found in the motions and chemical makeups of stars in this newly discovered outer disk. By studying these distant stars, we can essentially perform galactic archaeology, uncovering the violent and dramatic history of the Milky Way's formation in unprecedented detail. This expanded territory is a treasure trove of historical artifacts. And of course, the question that fascinates us all: are we alone? Doubling the size of the Milky Way stellar disk means we've also dramatically increased the number of potential homes for life. We now estimate there could be hundreds of billions more stars within our galaxy than previously thought. This vastly expands the galactic habitable zone, the region where conditions might be right for liquid water to exist on a planet's surface. While the outer disk stars are older and have fewer heavy elements, the sheer increase in the number of planets to search is staggering. The search for extraterrestrial intelligence, or SETI, suddenly has a much larger playing field. The odds, while still unknown, have shifted. So what happens now? This discovery isn't an ending. It's a spectacular new beginning. Astronomers are now scrambling to survey this vast, unexplored territory. Future telescopes, like the Varici-Roubaix Observatory and the Nancy Grace Roman Space Telescope, are perfectly designed to map these faint, distant regions with incredible precision. They will help us create a new, far more accurate 3D map of our galaxy, chart the orbits of its outermost stars, and analyze their chemical compositions. We are standing on the shore of a newly discovered continent within our own galaxy, and the age of exploration has just begun. The story of the Milky Way is our story. It's the story of a universe that is constantly surprising us, reminding us that there is always more to learn, more to discover. The night sky, that familiar, comforting canvas, has just revealed a depth and scale we never knew it had. It forces us to be humble, to recognize that our knowledge is a tiny island in a vast ocean of mystery. As we continue to push the boundaries of science, who knows what other continents lie waiting to be found? The cosmos is calling, and our journey to understand our place within it is far from over. Thank you so much for joining me on this incredible journey to the edge of our galaxy and beyond. If you found this as mind-blowing as I did, please hit that like button and subscribe for more deep dives into the mysteries of our universe. What do you think this discovery means for the future of astronomy? Let me know in the comments below. See you next time.